In this video, we're going to go over a series of some more exercises about measures of central tendency to get us a little bit more practice computing these things and also maybe interpreting them a little bit along the way. So I'm going to try to throw at you several different types of exercises and see what you can do with them. So hopefully what you should be doing as you read along here and follow along with me is, as I present a problem, pause the video, work it out yourself, and then come back and hit play to check your answer against mine. You will learn a lot more from these videos if you will watch them in that way. Okay, so here we go. First question is, what if we're given a dot plot of data like we see here, and can we compute some measures of central tendency from that? And so the question is now, compute some different statistics. Maybe some, not only just measures of central tendency, but some things that we've done before. First, we can compute the sample size. We can compute the quartiles, but that includes the minimum, maximum, Q1, Q3, and the median. And then we can measure some other measures of central tendency besides the median. We can find the mode, the mid-range, the mid-quartile, and the mean. Let's see if you can compute all of those statistics. Some of those are measures of size, some are relative standing, and some are measures of center. So go ahead and compute all of those things now. Press pause. Okay, we're back. So let's see how we could do that. Let's look at the data set. The first thing is we can just simply count to find the total number of dots, and that's going to be the sample size. So I'm assuming this is a sample, not a population. So let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So the sample size, or N, is 20. The minimum is the lowest one. So if you look at how these numbers are spaced out, that's going to be at 1. So that's the minimum. And the maximum is the highest one, which is at 13. So there's the extreme values, the minimum and the maximum. Okay, now there's 20 of these things. So to find the median, it's going to be the 10th one from the bottom and the 10th one from the top, and then just add those two up and divide by 2. So let's see what that gives us. The 10th one from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is that one. And so that one should be the 10th one from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these two right here are tied for the middle in a ranked list, and they're both 5s. So that means your median is 5. So if we drew a line between those two, there would be 10 below, counting these two as in the lower half. Counting that one in the upper half, there would be 10 above. So the median is 5. Now, to find Q1, if we use the same method as used on a TI-84 calculator, for example, we would take the median of the lower half and the median of the upper half, and we're not going to count the mean as being part of either half. The median is part of either half, but see, the median is sort of between these two. So we're going to count the lower 10 and find its median. So that'll be between the 5th and 6th one from the bottom. 1, 2, 3, 4, 5. The 5th and 6th one are both 4s, so Q1 is 4. Okay, and then if we do the 5th and between the 5th and 6th one from the top, that will be the Q3. 1, 2, 3, 4, 5. The 5th and 6th one from the top are both 7s, so 7 is Q3. And so this right here is now your, sometimes called your 5-number summary. That is your 5 quartiles that we get. Okay, notice the median, the minimum, and maximum actually are quartiles. Minimum is the 0th quartile, the median is the 2nd quartile, and the maximum is the 4th quartile. All right, probably the next one I'm going to compute is probably the easiest one of the measures of central tendency to compute is the mode, and that's the one with the most dots. So that's this one right here, the most frequently occurring data value, which is 4. Notice the mode is not how many dots we have it for, but the x value or data value there, the 4. The mid-range, let's compute that next. So we go from the minimum to the maximum and go halfway in between those so that you're the same distance from the minimum and maximum. And so what we do is we take the minimum of 4 and the maximum of 13. We add those up, which is 17, divide by 2, and you get, let's see if I did it. You should get 8.5. Let's see. No, I'm sorry. Minimum is 13. Maximum is 13. Minimum is 1. Add those up, you get 14. And 14 divided by 2 is 7, and that's the mid-range. So notice that 7, the mid-range, is exactly 6 above the median and 6 below the maximum. So if we were to just draw this from 1 to 13, then 7 would be exactly in the middle of our screen, which actually it is because we just went one above them, below the maximum and the minimum there. And so 7 is the mid-range. The mid-quartile, once we have our quartiles figured out, 4 and 7, we just find halfway between those two, which is 4 plus 7 is 11, divided by 2 is 5.5, and that's the mid-quartile. Now finding the mean is a little bit harder to do. We have to actually add up the data values, all of them, and then divide by how many we have. So we're dividing by 20, but we have to actually add these up. So we'd say 1 plus 3 plus 3 plus 4 plus 4 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 7 plus 7 plus 8 plus 9 plus 10 plus 13. Add all those together and then divide by 20. And if I computed this correctly, that should be 5.7. Notice you could also do it this way. 1 plus 2 times 3 plus 5 times 4 plus 3 times 5 plus 3 times 6 plus 2 times 7 plus 8 plus 9 plus 10 plus 13, and then do all that addition and then divide by 20. Now, illustrate the quartiles by drawing a horizontal box plot using the same scale. In fact, let's just do it right here on the data. So if you could actually reproduce this on a piece of graph paper, then what I'd like you to do is to either right below or right above make the actual box and whiskers plot. See if you can do that now. Okay, and then illustrate the location of the other statistics on the graph as well. So here they all are. Okay, so here's the box plot. First of all, here's the minimum is the lowest one right here. That's the bottom of our whisker on our lower whisker. The maximum is the top of our upper whisker, which is 13. The box here of the box plot goes from Q1, which is 4, to Q3, which is 7. And technically Q4 is where this line is, so that there are 5 values below that. And then, well, there'll be 15 above, but 1/4 will be below. And this line right here is Q3, so where there are 5 above that, or 3/4 of the data below that. Okay, and then let's see, where are we? And the median is right here. Then we draw a vertical line in the middle of our box, well, somewhere between the Q1 and Q3. Where the median is, that's this red horizontal line, so that 10 of the data points are below it and 10 are above it, half above and half below, and so that's the mid quartile. So remember, these are measures of relative standing. So basically, 1/4 of the data is down here, from 1 to 4. 1/4 is between from 4 to 5. Approximately 1/4 is between 5 to 7. And about 1/4 is between 7 to 13. And it's fourths if you count, like for example, you count that 7, one of those is being the upper quarter, and the next 7 is in the third quarter right in here. So depending, if you sort of put them together like that, then it does turn out to be exactly 1/4 in each part in this case. Okay, so those are measures of relative standing. The mean is where I've got this point of this triangle right here is at 5.7. that would be the balance point if this was a center of mass. Or another way of saying it is, if we added up all these data values and divide by how many we have, that's the mean. That's also would be sort of the equal share amount if we divided it, had the same total, but everyone had the same frequency. Okay, then that would be at 5.7 each. So the 5.7, 20 numbers at 5.7 would be the same total as these 20 numbers at their various values. The mode is just the one that occurs the most often. We can see that here at 4. The mid-quartile is right here. And notice that line is exactly halfway between the line for Q1 and Q7. However, it's not the same necessarily as the median, or the mean for that matter. The mid-range is 7, which occurs right here, and that's exactly the same distance from the minimum up to the maximum. But notice in this case, basically a quarter of the data is above it and 3/4 below it. It's the same as Q3. So it's definitely not the middle in that sense. That would be the median, but it's the middle in the sense that it's the same distance from the top and bottom. Same way the mid-quartile is the same distance from Q1 to Q3. So you can kind of see all of those things actually showing up there on the dot plot. Okay. Okay, these, if you want to pause and read those, I think these things say just what I said. Okay, so the next one I'd like you to do this actually without a calculator. I've made it to where the computations are not too bad to do by hand. I made it a small data set, and I made it just, well, with one exception. These are single-digit whole numbers, and then one small 2-digit whole number. So we've got several small numbers, and I've made sure that there's not that many of them. Just 7 of them. So see if you can compute the 5 measures of central tendency for this particular data set. No calculator or computer for any part of this computation. See if you can do that now. Okay, well, the first thing we want to do is we want to put the data in increasing order. So if you look, that's 1, 2, 3, 8, 9, 9, 17. So here it is in increasing order. If it's in increasing order, we see that there are 7 data values. So that's an odd number. You do 7 plus 1 is 8, divided by 2 is 4. So that tells you the 4th one from the bottom and the 4th one from the top will be the same data value. It is 8. There are 3 values above 8 and 3 below 8, so 8 is the median. Right there, right there. The mode is 9 because it occurs more often than anything else. It occurs twice. Everything else occurs once, so that's the mode. What about the mid-range? The mid-range, you take the minimum, which is 1, the maximum, which is 17, do halfway between those. 1 plus 17 is 18, divided by 2 is 9, so the 9 is the mid-range. The mid-range and mode are the same, but if you look, all the rest of the data values, besides those 2 9s and 17, are actually below that. All right, now we need to add these up to find the mean. The mean's the hardest one to compute. Okay, so let's see what we've got here. Put the 17 and the 3 together makes 20. A 1 and a 9 makes 30. An 8 and a 2 makes 40. And then the other 9 makes 49 if you add those together. We're dividing by 7, so 49 divided by 7 worked out nicely. I was nice to you since I asked you to do this without a calculator. Turns out to be nice. It's 7. And so 7 is the mean. So in this particular case, the mean is 7, the median is 8, the mode is 9, and the mid-range is 9. All right, now, it's important that we are able to compute some of these measures of central tendency by hand, okay? And it is important we don't even be able, we should be able to do this without even picking up a calculator. So that shows, if we can do that, that we understand what the definitions are, we know how to compute them. But in practice, most of the time with statistics, the data sets aren't just a handful of numbers like this, and the data's real world data, so maybe these things might have multiple decimal points and you're dividing, it doesn't always work out to be a whole number and so forth. So in a real world setting, we're typically going to use some sort of technology to help us out. So now the next one is use some kind of technology, either preferably learn how to do it on all these technologies, your graphing calculator or Excel, or if you've got a statistical program available like maybe StatCrunch or maybe SPSS or Minitab or something like that, or just Excel. Excel is a commonly used tool or some similar type of spreadsheet. Take this data and compute those. Well, let's compute. How about we compute all the measures of central tendency, and you could also compute other measures if you wanted to. Like, of course, you're going to have to compute quartiles along the way anyway, and minimum, maximum at least. So you're doing some measures of relative standing as well. So look at this and see if you can do this. Press pause now. Okay, so we take this data and we can do this. Let me just show you how to do it in Excel real fast. So we can take our data set. Let's see if I can get it from here. And so we can copy this, Control C, go over here, Control V, and then we can get the rest of the table. Let's see here. Here, Control C, and of course, to do this, of course, you actually have to have the thing in front of you electronically. But we might have something like this for the data set. And let me just take this, and I'm gonna. I think maybe you can. Well, we can almost get it all here on one thing, but we have all of this here, and we can compute some different statistics, like just the number or sample size is n. And we can do that with Excel like this way. We can say equal count, and then always with Excel formulas start with an equal, and we can just count them. Of course, it's pretty easy to count by hand. So we have that. We also have, let's say we wanted to do the minimum, Q1. The median, Q3, and the maximum. Okay, so it's just max, and then look at your data set like this. That easy to do. Let me center these here. Okay, and same way for minimum, it's min is the command. If you're not sure what the commands are, let's go, for example, quartile. Suppose we don't know that. We can go up to this this fx, this function, and click on that, and we can go here, most recently used, but you can also go down to statistical and look up some different things. So let's just see, there's a whole bunch of them here. Some of these you may know what they are, and some maybe not yet. Okay, here we have quartile. Actually, there's two different versions in this version of Excel. I'm not sure which one is going to give us which, so let me do a little bit of research here real fast. Okay, I'll have to do some more extensive research later to see this, but there, as we've talked about in earlier videos, there are multiple ways we can compute the quartile, and now it looks like the newer version of Excel now has two different versions. I'll have to look these up to see exactly which one does exactly what here. I'll have to experiment with this to see, but for now let's go ahead and show you how this is computed. Let's say we use this one, this version here. The way you run them is the same. So you click on this, and with the function wizard, then you type in, you put in your array here, which is your range of cells, which I can just highlight the cells that I want where the data is. And then if I can put, of course, Q0 is the minimum, Q4 is the maximum, and Q2 is the median, which usually you do those by max, min, and median. And then you just mainly use this for 1 and 3. So the first quartile, the lower quartile, we push 1 here. And that's computing it with one method. And the other method, I think, I remember which one I just did, is this one. I think it's this one. So exclusive and inclusive. Probably, no, that's the same one again. Okay, let's do this again. So data there and this here. Now, of course, if you know the function, you could have just typed in equals quartile.exe range and so forth like that. So there's two different ones. This is the exe version, and this is the inc. So inclusive and exclusive. This probably has probably what this means is I'll have to check this out, but whether that it's including the median as part of the lower half or not. This is probably excluding the median for the lower half. If so, that would be the same as your calculator would produce. Then this one over here is including the median in this lower half. That would be the Tukey method. Now, the way Excel used to do it was different from either one of those, so I'm not sure exactly what's going on there. Now, this one is just equals median, and you highlight the data and that, and then again I'll compute the Q3 both the different ways. So again, I can go from the wizard. Let's see how that works again. You hit the insert function, you go down to quartile, and then I think I have the inclusive one on the left, so I'll do that one first and put in the data range there, and this is the third quartile. That's the exclusive version, and then we'll do the inclusive version. Now we'll do the exclusive version here. So this is the way you're going to compute things in practice. You're going to use some tool like, I just did the same one twice. That's the exclusive. No, I didn't do the same one twice. In this particular data set, it just turns out to be the same answer. And sometimes different methods give you the same result, and sometimes they give you different results. So those are the measures of. So this is measure of size in. Then we have the measures of central measures of relative standing, the quartiles here. And then for measures of central standing, or central tendency, we have the mean, the median, the mode, the mid-range, and the mid-quartile. So then the way we compute that, well, the median, we already computed that, so that's the same as there. It's also a measure of central tendency as well as a measure of relative standing. The mean is what they use average in Excel, so equals average. And then you highlight this. And so that will compute the average, or the mean, what they call the average. The mode in Excel is mode. And we me highlight this and we'll see if there is one. There may not be one. I guess there was one there. Now the mid-range, I don't think Excel has a mid-range command. Let's just check. I recently upgraded my, so I don't see any kind of mid-range or mid-quartile thing. So, but we can compute those from what we have up here. So I can just say the mid-range is parentheses minimum plus the maximum parentheses divided by 2. That's mid-range. And similarly, the mid-quartile equals parentheses Q1 plus Q3 divided by 2. And we can compute all of those. Now, how about computing these on the calculator? For example, this is a TI-84 here. Let me clear out some stuff. Let me just clear out some stuff I might have running there. Okay, so go to Stat and Edit. And the first thing you do is put your cursor up on the L1, for example, hit Clear and Enter. And then we type the data in. Okay, 22, enter, 20.9, and enter, and so forth. I'm going to pause and let you type these in. Okay, press pause and get your data entered in. Okay, so I've entered all the data in now, and then this is what we have here for the data. So if I go Quit, and I go to Stat, Calc, one variable statistics, number 1. The list is L1, so that would be second 1 to get L1. The frequency list, I should put 1 because everything is actually just leave it blank. So everything has frequency 1, or it's listed there. Now, if you actually had a data table that was a frequency table with data and frequencies, then you'd tell the list where the frequencies are stored there. But we just do it like that, and we say enter. And so, or if you have the older system, it'll just say, it won't have that little wizard page that I just came up with, but it'll just come up as one variable stats, and then you just say L1 and enter, and it will figure out X bar, which is the mean. So notice Excel had it as 22.15625. This is exactly what happens here. It'll add up the x's, which is 709. It'll add up the x squares. It'll find the standard deviation if it's a sample or if it were a population. We'll talk about that in a later video. The n is 32, which is the sample size, which is what we counted over here in Excel, or we could count that by hand pretty easily. The little down arrow says there's more. And when you go down, we see the 5-number summary, at least as Excel does it, or as a TI-83 calculator or 84 calculator does it. 4.6 is the minimum. The maximum is 41.1. The median is 22.65. Those all agree over here. Everybody does that the same way. And the Q1, according to the TI-84 method, is 13.75. And the Q3 is 30.1. 30.1 agreed with both methods that Excel did. The 13.75 is between the two methods that Excel gave. So assuming I didn't make any typos in my data here, we see that the Excel must be doing something slightly differently for its two methods than the TI-84 does. So there are different methods of doing the Q1 and Q3, but you still get the basic idea. And of course, with those values, then you're going to get slightly different values for the median, for the mid-range. Well, no, you get the same value for the mid-range. The mid-quartile is the one that might be different because you'd be subtracting these two quartiles, Q3 and Q1, here as opposed to the various ways we might do it over here. So, and the TI-84 method, all of them were the same except for these. Let me type those data values in. They were 13.75, and it was still 30.1 on the calculator. And so in that case, the mid-range would be 21.925 there. Okay, so let's go back to our data set and see if we have any other other questions. Let's see, the old way, let's see, mid-range was 22.85 the way Excel used to do it. Okay. Well, that's anybody's gonna do it that way. Mid quartile 22.1125, and so the old Excel way is this one here, which is the inclusive way, quartile INC. That's going to be the old way Excel used to do it, but Excel has put in a new way to do it here as well. Okay. Well, here's another data set for you to use, and say maybe use TI-84 to do this data set. Okay, so press pause and do that one yourself. Okay, so press Stat, put in your data, go to Edit, put in your data, and clear L1, and then enter the data, press Enter after each one. Then go to Stat, right arrow to Calc, choose number 1 variable stats, put in L1, and enter, and it comes up with the statistics here, which if you did it right and typed everything in correctly, you hopefully will get the same information as this, the mean of 41.28, the sample size of 25, minimum of 10, Q1 is 30.5, median is 43, Q3 is 52.5, and max is 70. Now, it doesn't directly tell us the mid-range and mid-quartile, but they're easy enough to do. You can just do Q3 plus Q1 and divide by 2 to get the mid-quartile. That was the 41.5. And do the maximum plus the minimum divided by 2 is the mid-range, which is 40. You can also do you can also get your variables from the screen like this by pushing the variables key, which is right here, this key. And if you do this right after you've done these calculations, these will be the right values. So you go down to 5, and notice you can see different statistics there, some different other ones here. Under points, you'll see Q3 and Q1. So you could say, for example, Q1 plus, really I should put parentheses first, shouldn't I? So let's start with that. Parentheses, variables, number 5, points, number 7, Q1 plus, let's do that again, 5 points, I bet it's number 8, let's see, no, it's 9, and there's the mid quartile for the last data set, not for this one. Okay, so anyway, if you do that data set, you can compute it this way at 41.5, or you can actually type the numbers in this way. And similarly, you can use the minimum and maximum to find the from the variables list if you don't want to type them in again. In this case, it's pretty easy just to type them in. Now the mode you can't see that on your data list. But if we take a data list like this, one thing we can do is go to Stat. No, don't go to Stat. Excuse me. We go to List. So second stat is List, and you go to Operations. You can either sort in an ascending or descending order. So I'm going to choose, say, sort ascending. My list 1. Now remember, this is the data from the previous problem, and now it just says done. But if I go to Stat and Edit, the data before was written in the order that it just happened to be in the table, and I can see the data here in order, and I can start to look for repeats. And so far I haven't found any, so there may not be a mode. Oh, there's a repeat, 30.1. I think that, let's see, is that the only repeat? Yeah, it looks like 30.1 is the only repeat. So that's going to be the mode for the last data set, that one up here. And it turns out on this particular data set, the one that we had right here, when you put it in order, there's actually, I guess maybe no repeats, or there's multiple ties. I don't see, right off the bat, I don't see any repeats, but it turns out the mode is undefined there. Okay, how about another example? Compute each of the 5 measures of central tendency for the heights and inches of the players of a women's soccer team given by the following frequency table. And you can use technology if you want. So here we have heights and frequencies. So what this means is we have 2 that were 64 inches tall, 3 of the players were 65 inches, 5 of the players were 66 inches, and so forth, with the tallest one being 70 inches. Okay. So we can easily see the mode. It's just the one that occurs the most often, the highest frequency, that's 66. The mid-range is also pretty easy to calculate because there's the maximum and there's the minimum. So we just add 64 plus 70 divided by 2, we get 67. Now the median then, let's see, how many of these do we have? Well, let's count it. Let's add up all the frequencies here, and we get the sample size. And I believe those add up to 18. So the ones in the middle of a ranked list would be the 18th one from the top and the 18th one from the bottom. So let's see from the bottom here. Let's see, do a cumulative. There's 5, 10, 12, 16, 17, 18. So we need to go to the 9th one, half of that. 9th one from the top and the bottom. So there's 5, 10. The 10th one from the top, from the bottom one, is the 10th one from the bottom is the 9th one from the top, it's 66, and the 9th one from the bottom is also 66. So averaging those two does give you still 66. So 66 is the median. The lower half of the data will have 9 points. So the 5th one from the bottom is the median, as the Q1, which is 65, and the 5th one from the top, which is 68, will be the Q3. That's using the TI-84 method. And so the mid-quartile is halfway between those two. 65 plus 68 divided by 2 is 66.5. Now, if we want to add the data values, you could do it like this. 64 plus 64 plus 65 plus 65 plus 65, and so forth like that. But of course, we can also do it this way. Just take each data value and multiply it by the frequency. So 64 times 2 is 128, 65 times 3 is 195, and then add up these height times frequencies to get the total. So that's going to be the total of 1198, and then of course divide that by the sum here of 18, and that gives you, there it is in fraction form, not reduced, and in decimal that works out to be approximately 66.56. Now one thing that's kind of interesting is this is all over it's all over 18, or it's 1/18th times this. We can distribute this and then put it under each one, and it would be 64 times 2/18ths, plus 65 times 3/18ths, plus 66 times 5/18ths. That 2/18ths, 3/18ths, and 5/18ths are the relative frequencies. Okay, and so one way we can see is, by definition, x bar is add up all the x's and divide by how many you have. But another way to find it is multiply x times the p of x, which is the relative frequency, or the probability of choosing that x at random from this group, which is why I used a p here, but that's the relative frequency. So it's x times the relative frequency and add it up, or x times the probability and add it up. Now another thing, if we just look back at this, notice that all these are relatively close. All these measures of central tendency are between 66 and 67. So that tells us that this data set is probably very close. It's quite close to being symmetric. And it mounds, the highest one is close to the other measures of center as well. So it could probably be modeled relatively satisfactorily with a normal curve. Okay, now let's see if we can do this next one based on what we just learned on the last one. Compute each of the 5 measures of central tendency for the data set, giving not frequencies this time, but relative frequencies. Okay, well, what we can do here is multiply the x's times the relative frequencies. So think of this as a decimal. 0 times 0.1 is 0, 1 times 0.2 is 2, 2 times 0.3 is 0.6, and so forth. So multiply these two to get the one here. Then add these up, and that will be the mean. Okay, and so that will give us, that's the way we can compute the mean. Minimum is the smallest one, clearly 0. The maximum is 6 because it's already put in order. And so the mid-range is just average 0 and 6, or halfway between 0 and 6, which is 3. And we can find quartiles by kind of looking at the cumulative frequencies here. 10 plus 20 is 30, 10 plus 20 plus 30 is 60, and so forth. And we see that the median is, well, we haven't hit it yet with 1, but we've passed it with 2. So 2 will be the median. And the first time you hit 25% is going to be at the 1. The first time you hit 75% is in the 3. And so Q1 is 1 and Q3 is 3, so the mid-quartile is halfway between those, which is 2. The mode is the one with the highest relative frequency, which is right there, which is 2. Now, what if you're given a grouped frequency histogram or grouped frequency table? If you've got a group frequency histogram, you can make the table from the histogram. So, for example, you have something like this. This is ages of the U.S. presidents at their first inauguration as of when I'm recording this. This goes through President Obama. And if there are 40 to 44 ages in there were 2 presidents that were in that age range. 45 to 49, there were 7 there, 13 in their lower 50s, 11 in their upper 50s, 7 in the lower 60s, and 3 in their upper 60s. Now, which of these? So can we compute these measures? Well, the answer is we really can't. We've lost some data by these grouping it together. We can't truly know, for example, what the minimum is, or what the maximum is, and so forth. And we can't really compute the mean. Now, what we can do, however, is give an estimate of the mean. And the way we do the estimate is we take the midpoint of this range here for ages. Okay, so halfway between 40 and 44 is 42. So we assume they were all at 42, which of course is probably not true. But assume we have a frequency of 2 with the data of being 42. And then halfway between 45 and 49 is 47, so we assume that's 47. And so that's called the class midpoint, 42, 47, 52, 57, 62, and 67 with the frequencies. And of course, divide by 43, these are the relative frequencies. We multiply the class midpoint by the relative frequency, multiply those two, and we get this number. We do that for each one of these, and then we add up these things here, and that will give us the mean. What is that doing? That's assuming that, for example, all 11 of these are actually 57 years old. Probably not. In fact, I know they're not. So this is an estimate only. Now, actually, it turns out I know what the actual data is, and I worked this out earlier in Excel. So our estimate of the mean, let's say to 2 decimal places, was 54.67, and the actual mean computed to 2 decimal places is actually 54.67. Actually, actually we were pretty dead on for 2 decimal places, but that doesn't always happen. Usually you can get pretty close with this method, but it's not always that close. Okay, here's another real-world problem that some of you are, if you're a student in a class, you're going to be interested in this type of a problem. Suppose a student in a class whose grade is made up, say, entirely of 5 equally weighted 100-point exam scores, and that's the only thing in the class. And his grades on the first 4 exams are 75, 82, 64, and 71. What's his current mean? Well, that's easy. You just add them up, divide by 4. You add those 4 up, you get 292. Divide by 4, you get 73. So what's his highest possible mean score for the semester? Well, that would be to take this and add in 100 for this 5th test. So we take the sum so far, 292, add in 100, and divide by 5. So the best he can do is a 78.4. What's his lowest possible? Well, if he just made a 0 on the last test, then he would add 0 to 292, is still 292, but this time divide by 5, and is a 58.4. So he's guaranteed at this point, assuming nothing changes in the grading policy, he's guaranteed to make something between a 58.4 and a 78.4. Most likely, he'll probably stay close to his average so far, which is 73, but he could move it a little bit. So how much does he have to make on his last exam to, say, keep a 70? Suppose a 70 is the minimum C. He wants to keep a C. And how much does he have to make? This is a type of question that students ask all the time when they're going into the final exam of the semester. How much do I have to make to keep my C, for example, or to move up a letter grade? Okay, well, a couple ways we can think about this. We can do it as an equation. 292 plus x divided by 5 is 70. So multiply both sides by 5. 292 plus x is 350. 350 minus 292 is 58. So 58 is the lowest he could make and still keep his score to be 70 or higher. But here's another way that I want you to think of this, and I think this one helps gain some insight into what the mean means. Remember, the mean is like the fair, well, not necessarily fair share, but equal share amount. So another way of thinking of this 73 right here is to say it this way. What if he had his same total, 292, but made the same score on all 4 of the first exams? So making a score of 73 on the first 4 exams would give him exactly the same average and exactly the same total points as making the scores that he actually made. So let's think about it. If he makes a 73 if he makes his current average, his current mean of 73, if he makes that on the 5th exam, his average is not going to change at all. His mean will not shift. Well, to make his mean go up 1 point, since you're dividing by 5, he has to make 5 points above this mean to go up 1. So if he wants to go up 1 point to 74, average, he's got to make 5 points above a 73. He's got to make a 78. Okay, if he wants to consider what's going to happen to lower his exam score one point to 72, he'd need to make 5 points below his current average of 73. So to go down 3 points down to a 70, he would have to do 5 points per point he wants to lower. So that would be 3 points each to lower at 5 points each. So that would be 3 times 5 is 15. 73 minus 15 is 58. Now, of course, this is also assuming no rounding at all. We're going exactly a mean of 70. If he's allowed some round off and 70 is a minimum, then he might be able to go a little bit below that, and we could also work out what that would be as well. All right, here's a similar problem. Suppose that a student currently has a mean score of 75%. Suppose that 20% of the course points remain. What's her lowest possible mean score for the semester? Well, we can find the weighted average. The 75% she currently has is 80% of the course grade. And the 0%, which would be the lowest that she could make on the final, is the remaining points is 20% of the course grade. if you multiply this out, 0.75 times 0.8 plus 0 times 0.2, that turns out to be 0.6, or 60% is her minimum. What's her highest? Well, the highest would be if she make 100% on what's left. So that would be 0.75 times 0.8 plus 100%, or 1 times 0.2, which would be a total of 0.8, or 80% is the, that should say maximum. So 80% is the maximum score for the semester, 60% is the minimum for the semester, and she's currently somewhere in between those at 75%. So if she wanted to lower her grade, well, she doesn't want to lower her grade to 69%, but she's afraid that might happen, let's say, and so she said, well, what do I have to do to keep it at least above a 69? So what's the cutoff there? Well, 20% is 1/5. So this situation is very similar to the one in the last problem. Lowering her grade to 69% is lowering it by 6 percentage points. This will require that the grade is 6 divided by 0.2, or 6 times 5, is 30 percentage points lower than her current average. So currently she's at 75%. As long as if she makes 45%, then her average will be lowered to exactly 69% for the semester. You could check that by doing 0.75 times 0.8 plus 0.45 times 0.2 to get 0.69, or 69%. So as long as she gets above 45% or above, then her grade will be 69% or above. So if she wants to raise it to 80%, maybe that's the minimum B, for example, what would it take for that to happen? And we already computed that. 100% is exactly 80%. 100% on what's left will give her exactly 80% overall. So if she's in this situation and she wants a B, she better not miss anything on the remaining 20% of the course. Okay, let's do a couple more. Suppose that 20% of the points are left in a course. How many points above your current mean do you have to average on the remaining points to raise your overall mean by 1 point? Actually, we also answered this, which is 5 points above the current mean to raise your score 1 point. For every 5 points you make above your current mean, you will raise the final grade, the overall grade, by 1 point each. Suppose 30% of the points are left in the course. How many points above your current mean score do you have to average on the remaining points to lower your mean? How many points below your current mean do you have to average on the remaining points to lower your overall score by 3 points? Now, you would need to score 1 divided by 0.3, or 3 1/3 points above the current mean to raise it by 1 point, or actually it asks about lowering, so I'll change the answer to answer the question. So you need to make that much below to lower the overall mean by 1 point. Okay, let's keep going with some more examples. Suppose that you have a particular distribution of data in a sample. Think of the dot plot of the data with the various measures of central tendency marked on the plot. You might want to experiment with an applet such as one of the gizmos to gain facility with some of these concepts, or you may want to experiment with some data sets either by hand or using Excel or Minitab or something like that. Under what conditions will moving 1 point change the mean of the sample? The mean depends on every data point, so if we leave all the points alone except we change 1, then the mean will be changed. Perhaps only a little, or perhaps a lot. If you take a data point and move it way, way high or way, way low, then it might move the mean a lot. But otherwise, if you move it kind of around in the middle, it may have a very small effect, but it will have some effect on the mean no matter what. Under what conditions will moving 1 point change the median of the sample? Well, basically, if you move a point within the lower half or you move a point within the upper half, it's not going to have any effect on the median. So moving a point across the old median from the old lower half to the old upper half, or vice versa, is going to move the median. So if you move it from the old lower half to the new upper half, that's going to shift the median by one, basically by one ranked point, which could possibly move it up. And similarly, if you move it from the old upper half to the old lower half, this may move it down. Okay. However, if the median is at a point with where the frequency was greater than 1, even this may not move the median up or down. Under what conditions will moving 1 point change the mode? Usually moving 1 point will have no effect on the mode. The only exception is when the point is at the mode and the place we move it to then has a frequency 1 less than the current frequency of the current mode, and then you have a new tie. And so then you might have a bimodal situation. But usually speaking, moving 1 point will not affect the mode. What conditions will moving 1 point change the mid-range? Well, the mid-range depends only on the extreme values. So moving any point will have absolutely no effect on the mid-range unless that point is actually an extreme value, or one of the points in the middle is moved beyond the extreme values to give you a new, lower than the old minimum or higher than the old maximum to give you a new maximum in. So basically what I'm saying is the only conditions that moving 1 point will change the mid-range is if moving that point gives you a new maximum or a new minimum. Otherwise, no effect. Under what conditions will moving 1 point change the mid-quartile? Well, basically the same answer as last time. Well, very similar to the answer for the median. If you move a point within the lower quarter or within the upper quarter, that's not going to affect Q1. And if you move it within the, so if you move, let's see, if you move it within the middle half, that's not going to affect Q1 or Q3, either one. And if you move it within the lower quarter or within the upper quarter, that's not going to affect Q1 or Q3, either one. So it won't affect the mid-quartile. Now, if you cross over what the old Q1 and Q3 are, move one from one quarter, the lower quarter, let's say, to the middle or to the upper quarter, middle half or the upper quarter, that's going to change it. If you take a point that was in the upper quarter and move it down to the middle or the lower quarter, or if you take one from the middle half and move it to the lower quarter or upper quarter from what was before, that's going to affect either at least one of Q1 and Q3, and so then that's going to end up possibly affecting the mid-quartile. Okay. Under what conditions will moving 1 point change some element of the box plot? Well, again, if you move points within one of the 4 quarters, that's not going to affect any of the quartiles, which are the elements of the box plot, the measurements in the box plot. So the only one to change one of the 5 quartiles is to move 1 point from one of the 4 old quarters to another quarter. Or moving extreme values in or out will certainly change your box plot, change where the whiskers goes. Suppose you have a particular distribution of data in a sample. Think again of a dot plot with various measures of central tendency marked on the plot. Under what conditions will adding a point change the mean? Well, usually adding a point will change the mean. When it won't change it is when the added point is the same as the mean. Okay? Of course, if the added point is relatively close to the old mean, then the change in mean will be really small. If the added point is significantly far from the old mean, it will shift the mean considerably. The larger the sample size is, the less adding 1 point will affect the mean. So adding an outlier can significantly affect the mean, especially if the sample size is small. Under what conditions will adding 1 point change the median? Well, if adding the point's the same as the old median, there's no change in the median. If the point added is different from the old median, and the old median is not a point with a frequency greater than 1, then adding a point will move the median a little bit. But at most, the median can change to a neighboring data value in the ordered list of data at most. So an outlier will have little effect on the median. It might just move it a little bit to the next nearest data point, but that's the most it can move it. Whereas if you add an outlier to a data set, the mean could really be moved drastically. What about under adding what conditions will adding a point change the mode? Well, most of the time adding one will not have an effect on the mode. If you don't have a most frequent one, adding another point might make you have a mode now that you've got one that's actually the highest, the most often occurring, most frequent. So you could get that. We could have a mode and then adding a point creates a bimodal situation because we could be tied now. But in any other case, adding a point is not going to affect the mode at all. What about adding a point? How does that affect the mid-range? Well, the mid-range only depends on the extreme values, so adding a point will not affect the mid-range unless that new point is lower than the old minimum or higher than the old maximum, so you have a new extreme value. So adding an outlier out beyond what was the old max or min can certainly affect the mid-range drastically, but adding something in the middle is not going to have any effect. And then finally, same thing, what if we add 1 point to a data set, how's that going to affect the mid-quartile? Well, adding a point will usually change one or both of Q1 or Q3, so adding a point will usually affect the mid-quartile, although usually it will not be very much, especially if the data set is large. Okay, let's keep going here. If a sample of size 20 has all the data values the same, except for one data value that's lower, what can we say about each of the 5 measures of central tendency? The mean, median, mode, and mid-quartile are all 20, and the mid-range is lower than 20. That's not true. The median, mode, and mid-quartile, are all 20. The mean and mid-range are lower than 20. Suppose we have a data set with n equals 12 and the sum of all the data is 546. For which measure of central tendency do we have enough information to compute this? Well, there's enough to make the mean, because we've already got add them up and we've got how many there are, so all we have to do is divide. 546 divided by 12 is 45.5. And notice now with only this information we can compute the mean, but we do not have enough information to compute any of the other 4 measures of central tendency from this data alone. Okay, how about this one? If the median annual salary for 4 employees is $65,000, then what must be true about the salaries? How many salaries could actually be 65,000? Well, let's think about this a minute. Remember, the median of 4 data values is the mean of the second and third data values in the list. Okay, so 2 of the salaries must be at or above 65,000 and 2 must be at or below 65,000. We do not know the number of salaries at 65,000. There could be 0, 2, 3, or 4 salaries at 65,000. We could have no salaries at 65,000, which would require the second and third salaries to be one to be 65,000 plus X and the other one would be 60,000 minus X for some value of X. Okay, and then the lowest would be, below that, 65,000 minus X, and the highest would be 65,000, higher than 65,000 plus X, at or above that. We could have the second and third salaries both be 65,000, in which case the other two salaries could be 65,000 or something else. So that could give you 2, 3, or 4. We can't have just one salary at 65,000 because 65,000 has to be the average of the second and third lowest salaries. If one were 65,000 and the other something else, then their average could not be 65,000. All right, here is some data, some data that was pulled at one point. Let's see, I guess back in February 2011 from realestate.yahoo.com for Fort Smith, Arkansas, where I live. It states that there are 5 new homes listed within 10 miles of the city. At this point, they are not been built yet, so the prices haven't been set, but are given as ranges. And we can see them there. And the website lists a central tendency. Which central tendency would you use and why? And I would say probably the median might be the best measure. The first house is an outlier, which we could talk about what that means later, but it's significantly lower than the others. And then let's look at what happens here. It could have a deceiving effect on the mean and mid-range. The mode doesn't even exist. But at the same time, even here, what are we going to use for the class representative? We're going to use usually we would use the midpoint of these two, average of these two numbers as representing this house and so forth. And so I worked that out here. Here's the low and the high for each house in list 2 and list 3. I put list 4, I put my cursor on list 4 and did L2 plus L3 divided by 2. And then that gave me the average of those. So I would use these 5 values to represent that. I might do some statistics based on those 5 numbers and find the mean of them, 135,479 and 40 cents. And here's the median here, about 140,900. And so here's the mean, median, and mid-range using that. The website actually did what they called the median price at 122,900, which is less than the median I did. So what did they do? Well, what they did is they did the median of these low end. So they took the low ends and did the median there. For some reason, that's what they did. So here's a challenge for you. See if you can make another table with reasonable house price ranges that are very different from the table above, but gives the same median by the method that the website used. Here's one example. Here's some ranges of houses. If you use this method of taking the low ends and doing the median, you get 122,900. But this is a very perhaps a very different grouping here, and we get by my method of taking the midpoint and then doing the mean, median, and range. If you look, those numbers are a bit different than the ones I had here. Basically, quite a bit higher, and yet using the website's method, there we get the same median. So what if instead of looking at the 5 new houses listed in Fort Smith, we instead looked at the total number of houses listed for sale, which was 748 at that time? What extra information other than median would you want to get an idea of the house prices in the city, and why would you want that information? Well, although a single statistic such as the median or the mean might give some indication of the center of the data, much more information is lost when using only one such measure. The 5-value summary given by the quartiles or a box plot gives quite a bit of information not only about the middle, but also the top and bottom, and even some indication how the values are spread out and distributed. So I would probably like to look at maybe a box plot. That would be pretty nice. Or if you could actually have a dot plot of all 748 homes, that would give the most information. But in this case of 748 dots, that's probably a little bit too much information. Now, one thing we could do instead is maybe round off the data to say the nearest 10,000 to get bigger groups, and then maybe use a group frequency histogram with about 8 to 10 groups, and that might give us a pretty nice representation and a feel for the distribution of the prices of all homes. So probably I would want something like maybe maybe the mean. That might be nice to know, but then also maybe a box plot, and then maybe a grouped frequency histogram. And you put all of that together, you could put that together in a nice little graphical summary pretty succinctly, and when you put those things together, then you'd have a pretty good idea of several things about these houses, and we could kind of get a feel for the housing market in Fort Smith at this particular time. Okay, well, this is a fairly long video as far as my videos go, but we covered quite a bit of different types of problems. Some of these may be a little more interesting kind of problems than you've seen before, and I think if you understood all of these problems, then you've got a pretty good handle on what's meant by measures of central tendency.